about 6 o'clock and we're going to get started. Turn that down just a tiny bit. Thank you all for coming. We're really excited to have Callie Moore here again for our third in the Fossils Rock lecture series. Callie is the manager of the UM Paleontology Collection and also a creator and host for PBS Eons. We also, just a little housekeeping, we have MCAT here to record the program. So at the end, if there's questions, I will come up with the microphone so that we can capture all your good questions for folks who will be wanting to watch later. So without further ado, welcome, Callie.
Can this sound good? Okay, cool. All right. I'm very excited to give this talk tonight. Under the sea, 325 million years ago, Montana's Bear Gulch Limestone. I originally made this talk for the 2022 Dinosaurs and More event down in Bozeman. And since then, I have given this talk at the University of British Columbia, at the Dino Shindig in Ekalaka, Montana, and just recently at the Paleo Fest outside of Chicago, Illinois, at the Burpee Museum. So a lot of people have gotten to hear about the Bear Gulch, and now I get to tell you guys about the Bear Gulch. This is the longest version of it. You guys are getting it all tonight, because most of these other talks have been about 20 minutes max. So I have like a whole 60 minutes. So I added some slides, I unhid some slides. So this will be the longest of the Bear Gulch talk. But let's get into it, because we got a lot of pretty pictures to look at. So tonight I'm going to go over the discovery, so the history of the site, and then we'll get into the geology, so the age and the formation, then the paleontology. This is where all the pretty fossil pictures will be. And then we're going to talk about this weird mystery fossil that people are still fairly unsure about. So let's get into the discovery, and the year was 1968. Two local ranchers, Charles Allen and Ralph Harton, were quarrying limestone, and they found a fossil fish. They turned it over to a UM geology student named Douglas Wolfe, who was home in Lewistown at the time, and he took the fossil back to campus for IDing. Now, where was this found? Okay, so here's this wonderful hand-drawn map, and down here at the very, very bottom, this gigantic arrow pointing at this little tiny X is basically where the formation is, and if we enhance, you can kind of see, whoop, enhanced too much. And so this little shaded box here is kind of the outcrop, extent of the outcrop just south of Beckett and Forest Grove, down away from Lewistown. And if we enhance a little bit more, here's a bit more of an idea of the extent of the Bear Gulch. So it is not very big. There's not a lot of places where the Bear Gulch outcrops. Actually, you're looking at it right here. And it's all on private land. So huge bummer. Now, what did they find? They found this fish fossil. This is Alenopterus montanus. And what's fun about this fossil here is that when you read some of the primary source material, like newspaper articles and things like that, they'll either say they found one or two fish. And they're technically both right, because this is actually the same specimen. So you will see in just a second how we process this material is we have a big slab of limestone and we bust it open. And a lot of times it busts open and we'll have part of the fossil on one side and part of the fossil on the other side. So this is called a part and counterpart. We have a lot of these in the collection. And so there were two fish fossils, but they were from the same fish. This was named much later, and it's now known as a coelacanth, and I always like to call it the hunchback coelacanth. And here's a little drawing of it, so you can get a better idea of what this little fish looked like. It had these kind of armored bellied scales, and its mouth kind of faced downward, so we think it was a benthic specialist. So it would swim around and then rest on the seafloor, maybe nibble up something, swim a little bit, rest, nibble a little something. Maybe if you've seen like a goby fish, probably a very similar lifestyle. Now, back to our story. So the first scientific investigations take place real quick because William Bill Milton was not able to ID that fish from the available literature. So he looked all over the place and there was nothing like it that had been published. So in April of 1968, he went out with some locals and some students from the U of M and they found another fish. And so this piqued his interest, and he went back in the summer and the fall with this guy named Dr. Ernest Gilmore, who had recently gotten his PhD looking at Carboniferous rocks, and they were all kind of like, yeah, we think this is from the Carboniferous. It's probably somewhere in the 300 million year range. So they went out to confirm that, and they did. They confirmed that it was Carboniferous. Then in July of 1969 was kind of the first big research season. And Bill Milton took this guy, you may have heard of him, Jack Horner, out into the field with him, and a fish specialist, Dr. Richard Lund. So that colored photo is Richard Lund, and then the black and white photo is of Bill Milton. So during that first 6-week field season in the summer of 1969, they found 65 fish specimens. That is a lot. That's a lot of fish. And they found some curious looking fossils, which we'll get into in just a second. So these were the first 2 manuscripts. It was actually this that fish that I first showed you, Alanopterus, was kind of talked about in this abstract for GSA. And then the very first publication came out in Northwest Science in 1969 as well. And it's talking about a Doryopterid fish. So at first they thought that Alanopterus was like Dory from Finding Nemo, but it turns out, no. Much different group of fish. So here's how the publications based on the specimens from the University of Montana have kind of gone. So of course, there's like one from 1969 or 2, but the heyday was definitely the 1980s, and it's kind of gone down from there, but almost every single year there's a handful of publications written using our specimens describing something from the Bear Gulch. So let's talk about the geology. And this is probably the best subtitle of a thesis that has ever been made: How Them Fish Swam Between Them Rocks. So this is the subtitle of Loretta Williams' 1981 PhD thesis, and she did the stratigraphy on this site. So she mapped the geology of the Bear Gulch. And the story goes, while she was out doing field geology and doing her field work, she came across some locals that are out there, and they wanted to know how them fish swam between them rocks, because all of the Bear Gulch outcrops in creek beds. So they literally thought that modern fish were being squeezed into the rock during like flooding season and things like that. It's like, no, these are 300 plus million years old. But because the fossils are so well preserved, it seems obvious that these are modern fish that got smashed between the rocks. So first off, the Bear Gulch limestone is a platenkalk, and what that means is it's a lithographic limestone. The little sediment grains that make up the limestone are very homogeneous. They're very fine grain, and you can do things like printing on them. And so that's why it's called a lithographic limestone. And this is very similar to the famous Jurassic Solnhofen limestones of Germany. Now, it's part of the Big Snowy group, we know that. But whether it's the Heath Formation or Tyler Formation is up for debate. Depending on who you ask and what papers you read, it's either or. And then this is where the very specific age, Arnsbergian, E2B, Serprukovian, Namurian, Mississippian, Carboniferous. So that's the full breakdown of time. So this is going from the broadest to the most specific that way. And based on the ammonites from these units, we think that it's about 328 to 324, 25 million years old. Now here's a basic example of the Bear Gulch, and here are some people for scale, to kind of give you a scale. They're kind of bent over, working at the rock or sitting down, but these are some pretty big outcrops. This is the largest one. This is probably the most famous of the Bear Gulch outcroppings. It's the Blacktail Creek, I believe. And this outcrop here is about 100 feet tall. So I also have some humans for scale, and you can barely see them. Here's half a torso right here. That's a half a human. So this is a very big outcropping. Now, unfortunately, this outcropping is completely gone. We've worked it to dust. So if I show you, these pictures are, I think, from 1973. This is a photo from Loretta Williams' 1981 thesis. So she probably either took this picture in 1980 or the late 70s. So you can see how much this stack has been worked down, human for scale. So that's how we work these units. We start at the top of these limestone outcroppings and we just start busting our way through it. So you can see how far they've worked down on this outcrop. So they take these big pry bars and bust these big flat pieces of limestone off and separate it out so you can kind of see how they're just nicely breaking here. This is really nice. And then we start busting them apart. Now, unfortunately, in the early days, we were obsessed with the fish, absolutely obsessed with the fish. And I heard through the grapevine that they actually used to just throw invertebrates away to focus on the fish. I've had a lot of people ask me, well, does anybody go and look at the tailings piles of what they threw out? I'm sure people have. But again, it's all on private land now, and so it costs money to get onto that land, and you probably have to buy your specimens also from the landowners, and it's just a pain. So anyways, we're breaking this off and busting those limestone pieces in half, and a lot of times we're getting part and counterpart. Now let's talk about the paleogeography. Where was Montana 325 million years ago? So here is the outline of Montana, and we're in this very famous big snowy trough. This is the western edge of the newly formed supercontinent Pangaea. So Pangaea has just kind of come together. It's not 100% yet. We're probably at like 85, 90% at this time. And we're on the far west coast. Now I want to draw your attention to this red line right here. This is the equator. So we were just north of the equator 325 million years ago in this lovely little embayment. And that star there is roughly where the Bear Gulch sits. Now, if we zoom out a little bit more, we can kind of see all of Pangaea. So Pangaea is this supercontinent that goes from the North Pole to the South Pole and kind of makes a C shape. But this is the key. This figure right here is really the key to understanding why we get such amazing fossils from the Bear Gulch. So the Bear Gulch sits right here on that little star. Now, it is sitting right on the edge of this tropical and arid fluctuation point, the zone of maximum precipitation fluxes, right? So what this means is that it sits on a time where a lot of times there's like hardly any moisture coming in. It's just hot and dry. And then you have a monsoon season, and it brings in a ton of fresh water. It's bringing in a ton of sediment from the land and washing it into the seaway here. So that does a couple of things. One thing is it turns your water kind of brackish. So it throws off the salinity of the bay. And if you're an animal that cannot handle like ranges of salinity, you're very narrow, that's a bad day for you. But on top of that, it's washing in all the sediment that is fueling algal blooms. So just like we see in the Gulf Coast today, the toxic algal blooms from the runoff from agriculture, just fueling these huge blooms of algae. Now, when the algae dies and starts to decompose, it actually sucks oxygen out of the water. So it creates these anoxic zones, these zones of no oxygen. And if you breathe oxygen, whether or not it's on land or underwater, that's also another really bad day for you. So you're getting these salinity zones that could throw you off and kill you. You've got anoxic zones that will definitely kill you. And then you've also got that sediment that keeps washing in. And so if you die and you find yourself floating to the bottom of the seaway, the chances of you getting buried quickly, which is key to fossilization, goes up monumentally. So that's what we've got going on here. We've got rapid deaths with rapid burials due to this fluctuation of precipitation. Now, this is the newest theory for the Bear Gulch. You can see, you might be able to see here, this is from 2021. So this is relatively recent. And for a very long time, we had no idea why these fossils were here. So now, let's get into the paleontology. This is my controversial statement that I don't know if this is going to be the hill that I die on, but I've said it enough, it might be. I truly think that the Bear Gulch and the Bear Gulch fossils are more important than our state's dinosaurs. Now, luckily, I don't think there are any dinosaur researchers in the group today, but there usually is, it seems, when I give this talk. And the reason why I say that is because, remember, the very beginning already, I showed you how limited this outcrop is. I also mentioned that some of the best outcrops that we had from the 70s and 80s are gone. So it's a limited outcrop and it's all gone now. And we have soft tissue preservation, like a lot of soft tissue preservation, like more often than not. So we're getting skin, scales, muscles, eyeballs, organs, insides, all sorts of stuff. You don't really find that with the, let's just say, Hell Creek Formation, for example, one of our most famous dinosaur-producing units in Montana. So yes, you get some cool looking dinosaurs, but the Hell Creek outcrops from about Canada all the way down into Wyoming, into the Dakotas, and halfway across the state of Montana. That's a huge, you've got a lot to work with. Also out in eastern Montana, it's almost all BLM land, so it's really easy to work on. So you have access to the land, it's all there. You don't get a lot of soft tissue preservation. And yeah, so there we go. There's my controversial statement for the evening. Now, the Bear Gulch is considered a Lagerstätte, and we have a couple in the state, not a lot, but this is one of them. And a Lagerstätte is just a really amazing fossil locality. So not only do you get a great diversity of life, you also get really, really well-preserved, diverse life. This is from a very cool book series from Estrella Vega, and they are like these accordion books, and it has a consistent evolution track through certain periods of the geologic timescale. This is from the Carboniferous book, and so on one side is this beautiful screen printed scene of life throughout the entire Carboniferous, and if you flip it onto the other side, it has some information about what you're seeing on the other side. But she featured the Bear Gulch, so here's our friend Alanopterus. It's swimming for its life away from this Stethecanthus that we're going to talk about real quick. But I have to admit, the best diorama for the Bear Gulch is at the Museum of the Rockies. And you should go see it quick, because by 2025, it's probably going to be different or not there at all. So they're going to be redoing a huge part of the Museum of the Rockies very soon, and they're hoping to keep the Bear Gulch in there, but it will be different. I'm also going to take a lot of these specimens off display because they've been there for like 30 years. So we're going to give them a break and switch out some fossils. So if you want to see it as is right now, I highly encourage you to take a trip to Bozeman and check out this diorama at the Museum of the Rockies. Now, our collection at the U of M has about 4,500 specimens. And there's a big plus sign on there because I still haven't worked through the most material from a PhD that I think has ever been collected. So once I get through that, that number is going to go through the roof, and I'm sure we will definitely be over 4,500 specimens. Now, 42 of these specimens are holotypes. Holotypes are incredibly important. These are the namesakes of a genus species. So we are Homo sapiens, and somewhere in some collection there is the type specimen, the human Homo sapien skeleton that we compare any new Homo sapien skeletons to. So that's very important. So that's what's named. When we name something and give it a genus species name, we're using a holotype. So 42 are holotypes, 81 are paratypes. I believe these numbers are actually gone up because we've just had a couple of papers come out about some crabs. But anyways, 81 are paratypes. Paratypes are kind of like the supporting cast of the holotype. Maybe they show a structure a little bit better than the holotype did, but they're not as nice fully for the holotype. And then 89 total publications have come out of this collection. Again, I think I need to update this slide because I'm pretty sure there's been a couple more publications since I made this one. Here's how our collection breaks down. About 39% of the collection are vertebrates, and all of the vertebrates are fishies. And so we have chondrichthyes, your cartilaginous fish, your actinopterygians, your bony fish. Like if you think about a fish, you're probably thinking about a bony fish. And then your sarcopterygians. These are your lobed fin coelacanths. So we have these three groups of fish that lived in this bay. Now, 57% of the collection are invertebrates, and we're going to look at a lot of them, but there's crustaceans, brachiopods, cephalopods, worms, sponges, bivalves, conularids, gastropods, sea stars, arthropods. And so we got a lot of invertebrates. And so even with mentioning that some of the invertebrates got tossed off the side, a lot of them still made it into the collection. Now, the invertebrate collection is dominated by shrimps. Like 12 different species of shrimp. We had a lot of shrimps during this time. About 2% of the collection is plants. So that kind of makes sense since everything was killed by algae. We have a lot of algae. But we also have some terrestrial plants that were washed in from the land during those monsoons. Then you can't have all this life without having some coprolites. So we have a whole bunch of fossilized poo. At least like 1 to 2% of the collection is nothing but little turds all over the slabs. So now let's get into all of these pretty pictures of fossils. I'm going to start with the chondrichthyes. So these are the cartilaginous fish. And this is Balancia montana. And it's considered a petalodon fish. Petalodon? I don't have my notes. Anyways, basically think of a parrotfish. Parrotfish have those big giant teeth and they use them to like eat coral and bryozoans and then they poop out sand. That's probably what this one was doing. Eating coral, eating hard things, encrusting bryozoans, hard sponges and things like that. Now, it was built for maneuverability and not speed. We think it could really move, but it moved really slowly. And here's a nice little reconstruction of it from the PBS Prehistoric Road Trip with Emily Grassley. If you haven't checked that out, I highly encourage you. So that's one of our awesome chondrichthyes. Here's another chondrichthyes that is one of my favorites. This is Echinochimera miltonii, and it's a type of chimerid, just like a ghost fish. In our modern oceans. Now, there's a lot of cool things about this fish. One is we find 2 different morphologies on the same slab. So what that means is one of them's bigger and it has this big kind of dorsal spine here and it's got all these little spikies on it. And the other one still has a dorsal spine, but it's not as big, it's not as spiky. The individual is also smaller. So we're thinking male and female here. So a little bit of sexual dimorphism that we're finding. Also, we have babies. I don't have any pictures of them, but they're super cute. They got big round guts and big eyes, but they look almost exactly like the adults. So we have some babies of this species too. I wish you guys could see this, but there are speckles all over the body of this fish, and those are tiny, tiny, tiny little body scales all over this fish. This is Falcatus falcatus, and this is probably one of the most famous shark-like fish specimens ever, like in anywhere, not just in the Bear Gulch, but in all sharks or shark-like fish. Because this is Falcatus falcatus. The shark's so nice they named it twice. And we can see a couple of things going on here. So there's 2 very different fish, but they look very similar. One of them has this giant head spine, and the other one is like holding onto it.
I think your mic died.
Oh, no.
I'm sorry.
Oh, yeah.
Our rechargeable batteries are not top notch. There we go. Okay. So this specimen here is very important because we have 2 different morphologies on the same slab. This bottom fish here has this head spine. It's called a spine brush complex. And the one on top does not have a spine brush complex, and it looks like it's holding on to the head spine of this other one. So what does this mean? This means that it's probably male and female. And what are they doing? We don't know, but it is showing us some behavior. Whether or not we know what this behavior is, it is a behavior. So we have male, female, in a behavior on the same slab from this site. So this is a really, really, really important specimen, not just for, not for the Bear Gulch, but for fish anywhere and everywhere. So good old Falcatus falcatus. We have a lot of these specimens in the collection, and a lot of them are just that head spine. So it was tough material. This is Coelacanths, who was chasing after Alenopterus montanus in that little accordion book that I showed you earlier. Now, the specimen that you see here is actually the head spine. This is the spine brush complex right here, this big anvil kind of shape right here. And we think that they could move them forwards and backwards. Why? Who knows? Why did they have them? Usually in paleontology, if we don't know what a structure is for, we say it's for sexual selection.
So that's what we're going to go with today. Now, what's really cool about this is that shark skin is just basically modified teeth all over their body. If you've ever felt shark skin, if you go away from their face, it's super smooth. But if you come back this way, it's really rough. It almost feels like sandpaper. And the reason for that is because it's basically modified teeth all over its body. And what we find is up here at the top are a whole bunch of tiny little modified teeth. So it was almost like a rough, raspy patch on top of this spine brush complex. Again, why, we don't know. This is one of the larger fish from the Bear Gulch. It was probably over 1 meter long. But with this big head spine, it probably wasn't super fast. So it wasn't like the quickest fish in the sea, but it had the best mohawk for sure. Now we're going to get into the actinopterygians. So these are the bony fish. So like trout, salmon, etc., etc. Those are all actinopterygians. Now this one is one of my favorites of the bony fish. I have favorites of all the things. And this is Paratarsus hibberdi. Now what's really amazing with this fish is this incredibly long body fin that goes all the way down the length of the body. And what's great is you can see that in the fossil. It's really hard to see in this image, but trust me, it's there. So you can kind of see this shading that goes down the length of the body. And then if we had an even better picture of it, or if you saw it in person, you could actually see all the minute, tiny little bones holding that fin up. Now, modern fish that have this body design, this body plan, are usually living in like reedy, weedy type of environments. So they're going forwards and backwards, and they're hanging out in these really dense, probably seaweed or algal mats, or just the big plants or something down at the bottom of the seaway here. But it's absolutely amazingly preserved, and we've got the whole fish too, all of its scales, all of its bones, and probably some organs in there too. It's got a dark patch right here that's hard to see on this, but it's probably its last meal. This is Windiichthyes dickinsonii, and it looks a little bit more fish-like, right? You can like, okay, that's a fish. But what's really great is all of this like kind of reddish color that's on the fish is all of its original scales. All of its scales are still there. And the tiny little delicate fins of the tail are still there. Its whole skull is there. This is a really great, great preserved fish. This is another one of my favorites of the bony fishes. This is Discocera pectinon, and they're little. They're pretty small fish. Let's see, 1, 2, 3, 4, 5, maybe 5 centimeters high, 5 centimeters long. I always thought that they named it Discocera because it looks like a disco ball. No, it's not that cool. It's just a bladed disc, so like a saw blade, which is still kind of cool, but I think they missed the opportunity there. And we have a lot of these, and so we think they probably lived in schools. So they're all hanging out together, safety in numbers. But again, all of the scales are there. The tiny, delicate fins on the dorsal side and the tail fins are all still there. This is not Discocera. This is a very closely related individual. I couldn't find any images of Discocera, so I don't know why. They're not out there. Here's another pretty straightforward looking bony fish. This is Calops diophares. And again, just this wonderful preservation. All of the orange and dark coloration that you see is original scales. And then you can see it down here. So we have really good ideas of the skulls, of the scale patternings, how they fit together. Now we'll jump into the sarcopterygians, or the coelacanths, the lobed fin fish. And this is one of the most common. Actually, it is the most common coelacanth from the Bear Gulch. This is Cardiosuctor populosum. And what absolutely just tickles my heart is that at the very end of its tail, it's impossible to see on this image, but check it out on the reconstruction here, it's got this pom-pom at the end of its tail. And so what's really great, if I only have this half of the fish, if it's got that pom-pom, I know exactly what fish it's from. I talked to a lady at PaleoFest that studies aerodynamics, and she was really impressed when she saw this slide, and she knew exactly what that was for. And she says that this little pom-pom helps this fish turn real quick, keeps it steady, and it turns really quick. And now she wants to do a bunch of modeling on this fish, and I can't wait. I can't wait. So hopefully she finds out some cool stuff on our specimens, and we get more type specimens because of her research. We've also found Cardiosuctor with shrimp hanging out of its mouth. So we know that they were eating shrimp for sure. And sometimes eating really, really big shrimp that doesn't seem like it would fit at all inside of them. But whatever, they died before they could find out how bad that was going to be. This is the largest fish, we think, from the Bear Gulch. This is Strepisotus, and nobody has ID'd it farther than that. So if you need a project and you like to work on predatory coelacanths, this is your fish right here. All we have are scales. This big giant thing that's about 4 centimeters wide is a single scale from this fish. They get as big as 7 centimeters wide. That is a large scale. We have one slab that has some of these scales overlapping still in life position. One. All the other ones are individual scales, and then we do have some pretty large teeth. So this tooth has been broke in half, and then some of it has also broken off, but it's still, you can still see the outline. And again, that's about a 3 centimeter long tooth. So this thing wasn't messing around. Now I've had questions about, well, we've got such great preservation of all these other fish, why not this one? And another thing that comes up is some of the group members of this family, it starts with an R and it's got an I and a Z in there somewhere. But anyways, they are brackish water. So they live in the brackish areas, more of like a delta environment. So my assumption is the reason why we're not finding full fish is because they're dying way closer to land. They're decomposing a little bit, and then their remains are getting washed into the bay during the monsoon season. That's probably why we haven't found any full specimens of these. Now let's get into the invertebrates. There's like 130 species of fish. I could be here all night showing you pictures of fish. So we're going to move on to the invertebrates. And we'll start with the crustaceans because, again, we've got about a dozen species of them. And this one is really nice. That looks like a shrimp. I feel like anybody that were to bust this rock open and be like, yep, that's a shrimp. If I could just peel it off of there and boil it, and we'd have a nice shrimp boil. And we have tons of these. This is Agnimmacharis cornigerium. And basically everybody in the collection has spelled this name wrong some way or another. It's been a nightmare to fix all of them. But we've got a ton of this individual. And we think that Cardiosuctor was eating a lot of these. But we've also got weird ones like Paramictorus here that to me looks almost more like a giant water bug or something than a crustacean, but they think it's a shrimp, so we'll call it a shrimp. Now, one that's not put up here, Tyrannophontes, which is a great name, is actually the oldest member of the mantis shrimp family. So the mantis shrimp are those amazing shrimp that live in the ocean, and they're like rainbow colored, and they can snap their little leggies so fast that they can create like light underwater. You can't put them in an aquarium because they'll bust out. They're amazing. They can see every single wavelength of energy known to man, I think. They are absolutely ridiculous. And some of the oldest members of that group lived right here in Montana 325 million years ago. We also have a lot of cephalopods. So we have some of these really nice, straight, smooth cephalopods. So there would have been like a little squid thing living out this end. And then we have another one over here, Reticocycloceras, that's like ribbed down, but it's another straight cephalopod. So again, little squid thing living up here. And then we have several species of these coiled cephalopods. This one is almost impossible to see, but this is Stroboceras. Now, some of these individuals have preserved ink sacs still. So, which is really fun. The one that has the best ink sac did not photograph well. And so I put this one in here. And right up here, there's a jumble of fish scales. And so we call that a little food packet. So that's somewhere near the gut, and this thing was eating on some fish. It had fish for dinner before it died. So a lot of these Gordoconus beargulchiensis have food packets, have hooks. Their hooks on their arms are preserved, ink sacs preserved, and one of the oldest members of the vampire squid is also from Montana. That specimen is not from us, unfortunately. It's from the ROM, the Royal Ontario Museum. So it's not in this, but I figured I'd mention it. We also get worms. So, I mean, this is about as soft body preservation as you can get. There are no hard parts on these worms. This is all one worm. And again, if you could see this in real life, the segments are just absolutely beautiful all the way down this worm. And then this kind of like light halo that's around it is the spines. So this is a type of bristleworm. And this is the only name that I can't say. This is a Streptoscolex. Yes. But we've got several species of worms. That's not the only worm. That's just the coolest looking fossil of the worm. So we've got several different species of worms. Again, worms are like something that you never find in the fossil record. Now, echinoderms, we have two different ones. We have this one, Lepidastrella montanensis, which is kind of like a sunflower sea star, or like my pin, a crown of thorns sea star. So they got like a whole bunch of arms, basically. That's what these guys are. I think this one's a little bit closer to the crown of thorns than sunflower sea star, but I didn't look at the taxonomy before I came, so I don't know. But anyways, we've got a lot of them. There were quite a few of them, and it's almost just like an impression of it. I have to use low angle lighting just to get a decent photo of these. Now, this one is really exciting. Tell your friends, because it's unidentified. And it's the only normal looking 5-armed starfish that I know of in any Bear Gulch collection in the world. So it's very important. So 1, 2, 3, 4, 5, it looks more kind of like a brittle star than your average everyday sea star. But I don't know. So if you know any carboniferous 5-armed starfish experts, I've asked this at everywhere that I've given this talk, and I've had none come forward. Oh, wait, I did want to mention one thing about the echinoderms. So sea stars and crinoids are all echinoderms, and crinoids are called sea lilies. So they attach to the substrate and have this like almost flower petal looking head up top, and they set on a stalk. I should put a picture of one of these up here. They are one of the most common fossils from the Carboniferous. I grew up in Kansas, and you basically cannot touch a limestone without seeing at least a little segment of that stem. There are entire limestone beds that are called crinoidal limestones because the entire limestone bed is made up of just crinoid fragments. They're everywhere. You can find crinoid bits and pieces in the Lodgepole Formation in the Madison Group here in Montana. Easy peasy. And it's only about 25 million years older than the Bear Gulch. So you anticipate you find a bunch of crinoids here. Not a one, not a single one, not a crinoid stem fragment, nothing, none, no crinoids. So that's one of my biggest questions is where are all the crinoids? And I don't have an answer for that. I'm assuming that the bottom of this bay was too squishy. There wasn't any hard substrate for crinoids to attach themselves to. So they attach and they don't move. And so maybe it was too squishy? I don't know. But that's a big mystery for the Bear Gulch. Now we get into some arthropods. So these are, well, this one is a horseshoe crab. And what's fun is this is 325 million year old horseshoe crab. And I bet everybody in here was like, that's a horseshoe crab. So they haven't changed a lot. As David Attenborough said, they have found a winning design. And so they have not changed very much. So this is Paleolimulus longspinus. And there is another species from the Bear Gulch that is also found in the Maison Creek in Illinois, which is about 25 million years younger-ish, give or take. Maybe like 15 million years younger than the Bear Gulch. Then another not common character of the Carboniferous, but something that you find more often than not sometime are trilobites. And this right here, this is the back half, or a trilobut of a trilobite. So this is the pygidium. This is the back half of a trilobite. And this little 1/4 centimeter trilobut is the only trilobite that I know of from the Bear Gulch. Again, why? Also, this is pretty rounded too, so I'm wondering if the trilobites during the Carboniferous here in the equatorial zones of the west coast of Pangaea, maybe they liked it more brackish. So again, we're just getting something that's washed in from farther upstream. Maybe. But again, you would expect more than one tiny little trilobut. Conularids. These are very weird. We think for a very long time we did not know what they were. We have a lot of fossils of them. They're not common, but they're not quite rare. They're fairly common actually in the Bear Gulch, but they're very strange. Today we think that they are members of the true jellyfish family, but they're like armored jellyfish. So these are like shells on the outside. So they have 4-fold symmetry, which, okay, all right, that's what you're going to go with. And they're basically like a sea anemone that's been shoved into an ice cream cone that had 4-fold symmetry. But they have very characteristic sides to them. So you can see most of the conularids have these kind of wavy, almost bars that go across them. Now, a lot of times you just find them hanging out solo. But this one in particular are 2 that are right next to each other. So basically the first one stops right about here, and then there's another smaller one right next to it. So they are found in groups every once in a while, and they are found solo sometimes. So it seems like we have both going on in the Bear Gulch. We have some really, really tiny ones that are only about 1 centimeter. They're super tiny, all the way up to about 15 centimeters long, which after I did some researching, average sizes usually only go up to about 10 centimeters. So ours seem to be fairly large. So we might have a couple of different species. I have a little CF up here, and in taxonomy, that means kind of looks like. So nobody's come in and give it the, yes, I am the idea and I deem this paraconularia. But a lot of people have been like, it looks like one. So we'll call it CF paraconularia. I think this one looks a lot more like this other one called like dinoconularia from Manitoba. But what do I know? I'm not a conularid expert. But these are very, very strange. The other thing is they hold on. What's really fun is both of these images have like these little balls at the bottom for their hold fast. And what's cool about this specimen is this star shape right here. This has been interpreted as the hold fast for this conularid. They are very rare. You hardly ever get soft body preservation in conularids. So for a very long time, we didn't even know that they had like the sea anemone coming out the top. But we have found some sea anemone coming out the top of some other specimens from conularids. So these are really fun. I used to mention these and then never talk about them. And so you guys are the first group that I put in a slide for the oddly weird conularids. Now, the favorite part of the talk, for me at least, is the mystery animal. So I mentioned that in 1969, they found some unique looking specimens. And it was nicknamed the alien goldfish. So let me introduce you now to Typhloesus. This is a very strange creature. It's cigar-shaped. It's about 7 to 9 centimeters long. I want you to pay attention to this black dot here. We'll talk about it in just a second. So let's look at how this has been described or drawn. So I'm just going to go back and forth a couple of times. Yeah, it's super weird. This is kind of like our version of the Tully monster. If you are familiar with the Tully monster. Okay, so let's break down that drawing. So a lot of people have attacked this problem of this specimen, and we've gotten some very different ideas about what it is. Most people agree this is the posterior fin. This is a fin. It's got like this rudder-like look to it. It's got rods and cross supports. Okay, fin. Like I said, everybody has called this a fin. I thought it was a rasping organ when this looks like a file to me, like a big file. One of those big metal files. That's what that looks like to me. But whatever, fin. Okay, this is pretty consistently called the midgut. And what's cool about this is where we find conodont apparatuses. If you don't know what a conodont is, don't worry, we're going to go over it. But I have the apparatuses on my shirt. They are microscopic, and this is the only time I wear this shirt. That black dot is known as the ferrodiscus. So the reason why a lot of people become scientists is so they can shoot lasers at stuff. So anytime we see something weird on a slab, we got to shoot some lasers at it. And when we did shoot some lasers at it, we found it was really high in iron, and it's a circle, ferrodiscus. So it has a high amount of iron. What it's for? I don't know. We don't know. Some people think it's just a disc, and some people think it's a cylinder that goes through like the middle of the body. Sure, why not? This is where it gets kind of weird. A lot of people have called this a foregut, but other people have called this a nerve cord and a notochord. Those are two very different things. Actually, all of those are three very different things. So I don't know. Most people agree that this end is the mouth, and this is the butt. But some people have called this anal pore a groove that separated two body length keels. So it kind of had two fins that ran the length of its body. And then this is where they kind of got separated. And it makes it look like there's a butthole. Maybe, sure. So there's a lot going on, and there's a lot of different descriptions that have happened of typhloesis throughout the years. So let's start with the taxonomic history. The first time this thing was published was in 1973. And the reason why it was so amazing is because of those conodont apparatuses in the midgut. So paleontologists and geologists have known about conodonts for a really long time, but we only find their nightmare fuel microscopic tooth structures, and we never found their bodies. So we didn't know what they look like. So the conodont animal remained a mystery. So when we found conodonts associated with a body fossil, hot dang, we found the conodont animal. And it made newspaper, fronts of newspaper, mystery animal found. We figured it out. And so it was really, really exciting. Well, unfortunately, for little typhloesis, or what it was known before, in the 1980s, we did find a conodont body fossil, and it didn't look anything like typhloesis. So in 1990, Simon Conway Morris re-described typhloesis, gave it the typhloesis name, realized that there were several different species of conodonts in the midgut. And so it's like, it's not the conodont animal, it eats conodonts. So it's a conodontophage. So it's eating the conodonts, and say, okay, so it's not the conodont animal, it eats conodonts, but what is it? So in early 2022, science was like, it's an animal, full stop. That's where we were at. It's an animal. And there were several different groups working on it at the time in early 2022. But it gets weirder. So here's a conodont. This is what we know what conodonts look like. These are very tiny. They're only like maybe a centimeter to a couple centimeters long. This is their tooth structure. Oh, I forgot to put it in here. I was going to put a video. So if you look up conodont apparatus on YouTube, you'll find this video. And some really amazing scientists restructured these apparatus and put them into motion. So although they look like they could bore straight through me, they were filter feeders. So they used all of these tiny nightmare-fueled teeth to filter out tinier stuff from the water. But they move. It's absolutely bizarre. But here is a conodont. So that's what we think it looks like. That's what we know it looks like now. And then it's tiny little apparatus. So these are very, very blown up. Most of the time you can only see conodont apparatus in a microscope. So that's what a conodont is. Now, what about typhloesis? Well, in a late 2022, a new paper came out, yes. And it was based on new specimens. And now we're at mollusk. And we think it was a pelagic, so swimming around, predatory, shellless gastropod, so basically a slug, with a projectile radula, like a frog or a chameleon. So it could shoot its little radula out and bring it back. So a radula is the scraping organ, the feeding organ of gastropods. If you've ever seen a snail in a fish tank and it's kind of doing this number, working its way around, it's eating all of the algae. If you look really, really close, you should be able to see the radula scraping away. So it's basically just scraping away the surface. But Typhloesis, they think, took it a whole nother step farther. And here's the foregut. So they're thinking it's foregut here. But you had this little, basically, tongue that would shoot out and grab the conodonts and bring it back. Okay, sure. Why not? They do say in the paper that this is in no way, shape, or form the end-all be-all of this specimen. This is just the best that we've got so far, and they're very, very, iffy on the placement here. So if, somebody were like, you have to choose what Typhloesis is, this is what they go with. But for the most part, they're still like, this thing needs a lot more work, and we really have no idea, but here's our best guess. Challenge it, basically. So that's where we're at with Typhloesis right now, is that it is a pelagic predatory gastropod with a projectile radula, which, wow, just keeps getting weirder. And here's a beautiful little reconstruction of it from that paper. And what's nice is that it has this glorious kind of galaxy coloration on it. I doubt it actually looks like that, but I'm here for it. I'm definitely here for it. And just some selfless, shameless self-promotion. I wrote a book, and it's called Tales of the Prehistoric World. You can get it now wherever books are sold. I believe Fact and Fiction has some copies, and so does the Montana Natural History Center. I think it's here, so you can check it out. But it's for all paleo nerds, but it's rated technically for ages 8 to 10, and it's got 60 stories of paleontological discoveries and some really cool animals, and I worked really, really hard on it, and I hope you guys like it. And with that, I thank you. Any questions? Yeah.
Right at the end, you talked about that gastropod. What was the source of the iron? Do they have it here?
So the question was, what about that Pharodiscus? Nothing yet. Nothing. They don't mention it at all in the paper. It's a black dot, though, on the reconstruction. They do put it in there. So there it is. It's labeled FD, Pharodiscus.
Does anything else have anything?
Not that we know of. And that's kind of the big issue with this, is that it's so weird. There is nothing modern that even remotely looks like this thing. That there's nothing that looks like it today. So just like I said earlier, that this is kind of like Montana's own Tully monster. So the Tully monster is found in the Mazon Creek, very similar environment, a little bit more brackish water environment, closer to the terrestrial, still about 15 million years younger than the Bear Gulch. But the Tully monster was a weird one for a very long time. We think we know what it is now. I've heard a lot of grumblings about what we think it is. And so even that one is still on kind of weird footing because, again, there's nothing even close to it in the modern world. So that's usually what paleontologists do. We find something and we compare it to whatever closest it is in the modern world. And that can kind of give us some ideas about where would it have lived maybe? What kind of behaviors did it have? What group taxonomically does it belong to? Where does it fit on the animal family tree? No. Not with Typhloesis, at least right now. Hopefully we'll get some cooler techniques. Maybe somebody will synchrotron this and maybe get some more details out of it. There's new techniques coming out all the time for paleo. So we'll keep shooting lasers at this specimen and hopefully one of these days we'll figure it out or figure it more out than we have now. But yeah, back there.
Me? Yeah. Okay. Earlier, there was a slide of something that looked like a brittle star, and you said it was unidentified, but that is reminiscent of something that exists today. And so why has all this, I mean, I don't understand the difference between unidentified versus unidentified, but studying and trying to figure out what it is.
Yeah, that's a great question. So the reason why I have it unidentified is because nobody's given it a genus species name yet. So nobody has said this is et cetera, et cetera. Undoubtedly, there are not a lot of sea star researchers that work specifically in the late Carboniferous. I've heard of a couple, but I think they are emeritus now and would probably get really annoyed with me. Like, why are you ruining my retirement with these questions? So the torch needs to be passed. If you know anybody that's really into sea stars, tell them that they should study the ancient ones from Montana. But yeah, that's basically what it is. Like, we know, yes, it's part of the sea star family. It's probably more closely related to brittle stars, but a taxonomist who names things and figures out where they fit has not looked at it and at least given it a genus species name. So that one is ripe for naming. If you want to name something, it's ready for you.
How do researchers access the fossils? And I'm saying before lockdown, during lockdown, and now.
So there are a few different ways. Most of our specimens are on our online database, so you can just search through it and type in random keywords and see what we got. The Bear Gulch is one of our most well-known collections. So I think if you're a Bear Gulch researcher, you would not have been able to read one publication without knowing that we've got it in our collection. So that's usually how people find out about us, is that they're researching generally the Bear Gulch, or they're researching something very similar to the Bear Gulch. They get these publications, they're like, oh, University of Montana has it. They go to our website, they see that you can search online, they push in their little keywords, typhloesis, and then it'll pop up how many specimens that we have, and hopefully there's images of it. We're really trying to get images of every single specimen in the collection and on the database too. So hopefully typhloesis has some images and they'll be like, yep, that's exactly what I was looking for. Then they reach out to me, they give me their credentials. Like, we don't just give our specimens to anybody. So they need to be a researcher at a well-known facility. If they're a grad student, I need to talk to their advisor, because the advisor is going to be the one that manages the loan. And then I pack them up and send them off, so they don't ever have to come here if they don't want to. During lockdown, basically the same, except for when our postal service stopped. So that held some stuff up for a little bit. But once that kicked back in, we were good to go. And so I do appreciate people that can come to me, obviously. So those holotypes, I very rarely send those out. Like, you really got to twist my arm for me to send a holotype in the mail across the country. And so I'll do everything in my power to avoid that. But if my image taking capabilities is not what they need, or they have some type of equipment that they want to, shoot lasers at the specimen that I don't have, I usually relinquish. But I will usually only send them like one of them at a time or something. If it's a part and counterpart holotype, they'll only get part of it. Then they got to send it back, and then I'll send the other one back, just to make sure, like why the royal family doesn't fly all at the same time type of thing. So that's basically how we work. If any of you guys wanted a tour of the collection, I do small group tours in the collection by appointment only. And you can email me to set those up. Any other questions?
Is this the same sort of formation that is where the Wyoming fossil fish come from? They look much more modern than these.
Yeah. And you got good eyes, because they are more modern. So the Green River in Wyoming, very, very famous fossil locality. It's Eocene age. So it's like 40 million years old, for only just 40 million years old in comparison to 325. But yeah. Environment. Yeah. Right. So the question was, is there anything similar with the environments? Why we're getting the same kind of looking fish? Yes and no. So the Green River Formation represents a giant ancient lake. So it was an inland freshwater lake. But what's cool about lakes sometimes is if they get deep enough, you run out of oxygen at the bottom. So that's something like what we're seeing in the Bear Gulch. You get these anoxic zones, kills the fish, they die, they sink to the bottom. But if you have an anoxic bottom of your lake, it's not like there's a bunch of scavengers hanging out. There is no oxygen. And so you have a lot longer to just hang out dead on the bottom as you are slowly getting covered with sediment and things aren't eating you. So that's what we think is happening at the Green River. So it's a little different, but there are elements that are very similar. Yeah.
There's clearly technology that you're using to study these things and photograph them. You want to tell us something about that? How new it is? What the learning curve was for you?
I have to admit, I have never shot any lasers at these specimens. I just read secondhand. So I actually don't study the Bear Gulch. I've just worked in and around the Bear Gulch for 15 years that I've picked up a lot of this through osmosis. So a lot of the technologies that we can use are different types of photography are one thing that we can do. So sometimes the specimens will look better if we put them in alcohol, just like rubbing alcohol. We put them in rubbing alcohol, and for whatever reason, that brings out a lot more of the contrast, and then we photograph it that way. So a lot of the specimens that you actually saw were photographed through alcohol because they look better. Also, alcohol doesn't really hurt the specimens. It evaporates so fast when you bring it out of the solution that it just, and it's gone. So that's one way that we can see more details. Synchrotron scanning is very new, and I hear about it all the time, and I see what it can do, but if I had to describe to you what it is, I'm not sure I could. But I think it's very similar to like an SEM, so a scanning electron microscope. So these are big microscopes that shoot electrons at your specimen, and then they hit other electrons off, and it gives you an image. It's really, I took an SEM course, and I'm still like, sure, okay. It's like physics. I believe you that this is how it works. I get it, kind of. There's hopefully this researcher coming very soon to look at the Bear Gulch fish because he takes pictures under extended periods of UV light. So we shut off all the lights, and he basically gets a very, very high-powered black light and different wavelengths, and he shoots these images for like anywhere from 3 to 10 minutes under this type of light. Now, the reason why he does that is because sharks are cartilaginous. They don't have bones, but they still have cartilage. And sometimes there's like cartilage smears, for lack of a better word, on the slab that we just can't see in our normal light, but they fluoresce. And so if you hold it under black light for long enough, those structures will fluoresce different colors for different types of minerals. So apatite, potassium, calcium, they will all fluoresce slightly differently. And so you can see so much more structure. I'm very, very excited. He has always wanted to come shoot the Bear Gulch. Pandemic slowed him down. Saw him at Paleo Fest, and I'm hoping in the next couple of months he's going to be here and we're going to play with all of our shark specimens because basically he's getting so much information out of these photographs that every single ancient shark needs to be redescribed. Mike Eklund. He's very cool. He's done a lot of the Devonian sharks from like the Cleveland shales in Cleveland, Ohio. He's looked at some other things, but he's yet to shoot the Bear Gulch. So it's going to be a fun day. Sitting in the dark with a giant, overpowered, overpriced too, I'm sure, black light. Yeah.
So I saw you had the ammonite on the fossil. Do you have many of those? I'm guessing. Do are the horns on some of because I've seen some of those with the spines. Do a lot of the ones that come out here have the spines?
So I don't think so. It seems like we have a smooth version and then a ribbed version. So let me go back to that slide really quickly. Zoom. Okay. So here's like the shell here, and then it would live out here. And this one is all straight and all the shells are perfectly smooth. Then there's this one that's got all of these ribs on it, but no spines. But this little guy here is all smooth. All Stroboceras are very smooth. Most of these have been crushed really bad and the actual shell has dissolved. So what we're seeing is really just the imprint and the insides. So we have a lot of organs from these two. We have jaws and stomachs, all sorts of stuff. Now there are some really cool spiny ammonites in the fossil record. There is one that we only have some big pieces of it, but I'm anticipating that the shell diameter is probably a foot, but it is very ornamented. No spines, but it is much more rough and it has like ornamentation around it. But we don't have any full ones. They're all just big broken pieces that probably just need to be prepped out a little bit farther and we'd have a better idea. But I think there are about seven different species of cephalopods. So maybe we'll find some spined ones one of these days. I know we have spined brachiopods. So basically looks like a clam, only one shell is a little smaller than the other. They have these giant spines all over them. So we've got some spiny stuff, but not the ammonites. One in the back.
No, have you ever found petrified fish?
The question was, have we found any petrified fish? So technically, all of these are petrified, but non-flattened fish. So where they're still kind of full and look real still. I believe there was some fish found in the Jurassic of the UK not that long ago, earlier this year, late last year, and they were not compressed. They looked weird, like their eyeballs were like sticking out of their heads, like they were creepy looking because you don't normally find fish that look like that in the fossil record. All the fish that I know of from the Bear Gulch are smushed. They're flattened and not 3D. Not flattened? What? Man. Saskatchewan. You should send me pictures. I'm curious. You've piqued my interest. I want to see them.
You said that you will be changing out the exhibit at Museum of the Rockies. Is that because you are correcting information or just because that exhibit's been there for so long?
No, the information is still spot on as far as I know. The specimens need a break for sure. I would not want to be on display for 30 years straight. But basically, I've talked to the guy that's in charge of, if you're watching this, I'm talking about you, man. But he's kind of in charge of their renovation of part of the dinosaur hall. And they want to put in some Western interiors. See, wait, I'm not sure if I'm supposed to say any of this, actually. Don't tell your friends. This is secrets. Secrets here. But anyways, they're hoping to keep the Bear Gulch and work it into a much larger kind of Paleozoic Montana exhibit within the new exhibit. But I don't know if the diorama is going to stay or if they'll just take pieces of it, or if they're going to make a new one, or if it's just going to be a painting with some fossils in front of it. We don't know yet. But I'm really hoping, and he's hoping too, that the Bear Gulch will be represented still, maybe even represented better than it is now in that tiny little case that's smashed into the background that everybody walks past and they don't see it. They're missing out. But so hopefully it'll be a little bit more upfront. But yeah, I don't know if there's anything to change or update. Most of the fish, the coelacanths, the cephalopods, their names are pretty straightforward now. Not too many things have been named since like the 90s. So, questions? Yeah.
Is the Bear Gulch still being actively studied? Who goes there?
Right. So the question was, are we still working on the Bear Gulch? Yeah, we're still working on it. We still have several publications that come out about our specimens, but most people are working specifically in museum collections. So they're not going out and not collecting new stuff, which is unfortunate. Again, all of the good localities are either gone or on private land, and most private landowners will charge you for access. Then they go through everything that you find, and if you find anything good, they make you buy it from them. I know, double dipping, right? So that really discourages researchers because we don't like to pay for fossils. We don't think we should have to pay for fossils. They should just be accessible for researchers to research. That's what they're there for, not to make money with. So there are a couple of landowners that will let you on their land, but they're kind of at the edges of that embayment. So you're really only finding the invertebrates, the algae, none of the sexy fish. So they kind of get ignored. But I would say 99% of all the Bear Gulch work is done in museum collections. And anytime like Typhloesis got that kind of rebirth because 9 new specimens of it was donated to the ROM. So 9 specimens that researchers had never seen before became available. And boom, they wrote a paper immediately about them. And so that's kind of what we keep hoping for, is just private collectors will donate their collection and we'll get to see new stuff. Unfortunately, if you get on like Fossil Mall or eBay, you will find a ton of Bear Gulch on those sites. Yeah, it's pretty sad. It's pretty sad. Fossil Mall. Yeah, Fossil Mall. Any other questions? All right. Well, thanks so much again for coming.